Mars is the fourth planet from the Sun and the second smallest planet in the solar system, being larger than only Mercury. In English, Mars carries the name of the Roman god of war and is often referred to as the Red Planet. What exactly is space colonization? Space colonization, also called space settlement or extraterrestrial colonization, is the hypothetical permanent habitation and exploitation of natural resources from outside planet Earth. As such, it is a form of human presence in space beyond human spaceflight or operating space outposts.
Reasons for colonizing Mars include curiosity, the potential for humans to provide more in depth observational research that unmanned rovers, economic interest in its resources, and the possibility that the settlement of other planets would increase the likelihood of human extinction. On Earth, we face a lot of pollution, water shortage, global warming, deforestation, and many other problems. Difficulties and hazards on Mars include radiation exposure during a trip to Mars and on its surface, toxic soil, low gravity, the isolation that accompanies Mars's distance from Earth, a lack of water, and cold temperatures.
Transportation. It will take 9 months to reach Mars from Earth. Modern transport trajectories reduce the time to 4 to 7 months, but shortening the time will also require more fuel capacity and higher amounts of energy. To make it to Mars in less than 6 months, an increasing amount of fuel is required, which makes it practically impossible for chemical rockets. But during the journey, astronauts will be subject to radiation. Cosmic radiation and solar winds cause DNA damage.
Mars has a surface gravity of 0.38 times that of Earth, which means its acceleration due to gravity is about one third than that of Earth. Also, the atmosphere of Mars is about 0.6% than that of Earth. This makes it difficult to land heavy crewed spacecraft with thrusters only.
Gravity and magnetosphere. The surface gravity of Mars is just 38% that of Earth, although microgravity is known to cause health problems such as muscle loss and bone demineralization. Due to the lack of magnetosphere, solar particle events and cosmic rays can easily reach the Martian surface.
The Martian soil is toxic due to relatively high concentrations of chlorine and associated compounds, which are hazardous to all known forms of life. The potential danger to human health of the fine Martian dust has long been recognized by NASA. A 2002 study warned about the potential threat, and a study was carried out using the most common silicates found on Mars. It found that the dust reacted with small amounts of water to produce highly reactive molecules that are also produced during the mining of quartz and known to produce lung disease in miners on Earth, including cancer.
Atmosphere. Atmospheric pressure on Mars is far below the Armstrong limit at which people can survive without pressure suits. Since terraforming cannot be expected as a near term solution, habitable structures on Mars would need to be constructed with pressure vessels similar to spacecraft, capable of containing a pressure between 30 and 100 kPa. Due to the thinness of the atmosphere, the temperature difference between day and night is much larger than on Earth, typically around 17 degrees Celsius. However, the day night temperature variation is much lower during the dust storms when very little light gets to the surface, even during the day, and instead warms the atmosphere.
Mars has no rain and virtually no clouds. So, although cold, it is permanently sunny, apart from during dust storms. This means solar panels can always operate at maximum efficiency on dust free days. The temperature on Mars varies from minus 140 degrees Celsius to 30 degrees Celsius, with an average of minus 81 degrees Celsius.
Survivability. Although there are some extramorphal organisms that survive in hostile conditions on Earth, including simulations that approximate Mars plants and animals generally cannot survive the ambient conditions present on the surface of Mars.
The obliquity or the axial tilt of Earth is approximately 23.5 degrees, while the obliquity of Mars is around 25 degrees. One day on Earth is about 24 hours, while on Mars it is about 25 hours. Total land area of Earth is about 30% of its total surface area. This is equal to the total surface area of Mars.
Equipment needed for colonization are basic utilities like oxygen, water disposals, water recycling, etc., storage, workshops, energy production, food, transportation.
For communicating with Earth from Mars, you will require high-power satellites and telescopes. At the closest approach of Mars and Earth, the time delay will be about 3 minutes. At the largest aphelion of Earth and Mars, the delay will be 22 minutes. Real-time communication or internet relay chat will be practically impossible due to long time lags. We can use satellites at L4 or L5, Earth-Sun Lagrangian points. Due to time dilation between Earth and Mars, 1 Mars second will be equal to 1.027 Earth seconds.